Alright, so hey guys, AxiomaticUncertainty here, and I'm back with another video, though this is not at all related to any of the previous content on my channel, nor did I um, really intend to make it related. Frankly, um, I am not really interested in uploading any sort of game development content anymore, so I just kind of stopped doing that. I've been busy and I've also just not really felt that into it. But today I figured maybe we could do something else. I thought I would just go through, maybe solve one or two problems on binary search, which if you don't know is just an alternative to LeetCode. Um, I like it just because I like, the um, casual competitions that you can host on here and, participate in. Um, but yeah, this is just a sort of fun video. I figured, I've seen a lot of people do these sort of like competitive programming or like interview problems um, on YouTube and sort of trying to explain them. But one thing I've noticed is that they're very canned explanations, right? These people have usually done these problems before, and I figured that I would do a problem that I've never seen before, or at least, a random problem from the website. So yeah, what we're going to do is we're going to create like an invite-only room, and I'm just going to queue up a medium and see where that takes us. So let's load that up and let's start the room. Okay, so length of the longest balance subsequence. Um, so we want to return the length of the longest subsequence of balance brackets. So here we have this subsequence. Um, okay, interesting. Yeah, so I think the way in which we want to do this is we actually just want to keep track of like a depth. So my first thought when I see this is that every time we open a bracket, right, we can say like, so say we have this, right, our depth increases, right? Say we have like a closing bracket, our depth decreases. Anytime we have an unbalanced subsequence inside of here, so say like here, right? These two don't match up with anything before them or after them. So whenever we reach a subsequence here, like this, that can't be balanced with anything prior, our depth should be negative, in which case we can simply um, discount that value and set the depth back equal to 0 and not increment um, the number or the length of the balance subsequence. And at the end, what we can do is however many um, parentheses we have that are left over, we can just increment the length by that amount. So hopefully that explains my logic here. I think it should sufficiently to sort of work. And I think this should work. So we're going to try that. So I'll do this minus length plus I. So we'll increment, we'll move through the string. And we need two variables here. We need a depth, which we're going to initialize to 0, and a result, which we're going to initialize to 0. And at the end, we're going to return a result. So we'll just add that boilerplate so we don't forget it later on. I don't know if this is really a useful tip, but as someone who tends to forget little things, just going through problems like this during interviews, I find it helpful to actually make sure that I add my return statement at the end, my definitions at the beginning, and then fill in the body as I go. It's just useful, I think, organizationally, so that you don't have to worry about that stuff. And also then it's easier to find later on, think through it in a sort of modular way. So anyways, we're going to iterate through. And I guess since we only have two cases, we don't need a switch statement, but just keep in mind in the future that that would be useful. So we'll get the character here, and you can tell I'm using Java. Obviously not necessary, but I like to use Java. So we'll increment both our depth and our result. And otherwise, we're going to subtract from our depth, and then we'll check if our depth is less than 0, and we'll set it to be equal to 0. We could do this with a, we could do, depth equals depth.max, depth 0, and that would do this clamping operation, but this is just easier to interpret, I think. But anyways, this handles our two cases. And yeah, whenever this happens, we're going to ignore it, and we're just going to keep going. At the end here, though, what we want to do is, if we have any existing depth, so see here, right, if we just take this substring or subsequence, I suppose, you can see here that the depth here at the end would be 1, right? This is not balanced. We have one unbalanced parenthesis here, and so we actually want to account for that by subtracting off the end depth. And I think this should be sufficient, so let's go over sort of a run through of this code again, because I explained it a little bit quickly there. We're going to keep track of the current parenthesis depth, right? So we can think of it as a depth, right? We're essentially entering into an enclosed section of parentheses. And actually here, I did forget one thing. But yeah, I'll explain that in a second as we go through here. You can see we're going through all the characters in the string, right? And we're keeping track of how deep into these parentheses we are. Every time we go through, we add to the result, and we add to the depth if we're getting an opening parenthesis. Otherwise, we subtract from the depth because we know it's a closing parenthesis. And here, if the depth is 0, or is less than 0, sorry, meaning we've closed a parenthesis we didn't already have opened somewhere else, right, meaning it's unbalanced, we set depth to be equal to 0 again. And, most importantly, we do not increment the result, but otherwise we do have to increment the result, so that was the quick change I noted. And yeah, at the end, we check for unbalanced opening parentheses, and if there are any, we can subtract them off like this, and this should give us our result. Yeah, I think that this should work. Let's run this. And this is accepted, so let's try submitting and see what happens. And yeah, you can see we have solved this problem. So yeah, that was just a really simple run through. I think, if people like these, I could do more in the future. They don't really take that much time, and I kind of, should be doing these types of problems anyways in order to prepare for some interviews that I have coming up. But yeah, let me know what you think. If there's anything I should do better, maybe I should be doing like diagrams of these in order to explain like what I'm thinking as I'm going through. But yeah, I thought it would be interesting to try a version of this series where, I handle the problems naively instead of sort of looking at them and giving a more detailed explanation. I'll try to explain, on the fly what I'm thinking, how I'm approaching the problem, how I'm moving through it. So yeah, again, let me know. And that's it.